All right, Matthew, here we go. We're going to talk about arc length and sector area of the circles. Before this, we've been talking about the arcs on the outside of the circles and been talking about it in terms of how many degrees out of 360 degrees that arc was. And that's called the measurement of an arc. But now we're going to talk about the length of an arc instead, which is a little bit different way of thinking about the circle. So our question is, what is the difference between the measurement of an arc and the length of an arc? Because the two things are different. So far, we've done measurement of an arc, which was in degrees. Now we're going to start looking at length of the arc, which is like an actual measurement, like inches or feet or miles or whatever. All right, so here I've got a picture of a circle. Out there in red is our arc length. So for this one, it's just from here to here. What if we wanted to know if we're walking around this circle and we only walked from here to here, how many feet would that be? Okay, that's what's called the arc length. If we're asking ourselves, how far is it from this point to this point here, just walking around that part? Well, obviously it's a part of the outside of the circle. The outside of the circle, we call that the circumference. That's the perimeter of the circle. The formula for the circumference is 2 pi r. So 2 times pi times r. We can also call it, since 2 radiuses is the diameter, we could also say circumference is equal to pi times d, because diameter is 2 radiuses. You might be asking yourself, well, what is pi? Well, a long time ago, ancient people looked at circles. They started measuring them because I guess they didn't have anything better to do. So they start measuring the circles. They measured the outside of the circle. They measured the diameter of the circle. And I guess they're really bored because they started dividing. They took a small circle, measured its circumference, divided by the diameter, and they got an answer around 3.14. Then they took a bigger circle. They measured its circumference, and they measured its diameter. And what do you know? They got the same number, 3.14. Every circle that they measured the circumference of and the diameter of, they always got the same answer for the proportion between the circumference and the diameter. They always got 3.1415, blah, blah, blah. It goes on forever. But they got the same number every single time. So they started calling that number pi because it was always the same. So pi is just any circle's circumference, so the outside measurement, divided by its diameter. Doesn't matter how big or how small the circle is. If you divide its circumference by its diameter, you always get 3.1415, blah, 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 blah. You get pi. So it makes sense that circumference is pi times the diameter, because pi is circumference over diameter. And if you multiply circumference over diameter by diameter, the two diameters cancel each other out, and you're just left with circumference. And of course, circumference equals circumference. Anyways, you don't need to know that. That was just for free. You're welcome. So now let's talk about if we want to get just this red arc length here. How do we calculate just that portion? Well, I know that it's part of the entire circumference. So going all the way around, this is part of that. So it's part of the circumference, which is 2 pi r. Now, how much of that circumference is it? Well, it's going to be some kind of fraction. In this case, what we're going to do is we're going to look at the arc degrees. Remember, the arc degrees is the same as the central angle. So let's say that this one was 60 degrees right here. If this is 60 degrees, then the measurement of the arc is 60 degrees. If we want to find the arc length, this would be 60 degrees out of a total of 360. So you'd plug in 60 degrees here for the measurement of the arc, divide it by 360, and then multiply that by the circumference, 2 pi r. So this would be a fraction of the entire circumference. And the fraction is right here, arc over 360. Okay, let's look at a problem and see how that works out. Here I've got a circle. I've got a 90-degree central angle. And I've got 8 meters as the radius. Okay, and we want to know what the arc length is from A to B. So if I was walking along that, how long would that distance be right there? So if I want to find the length of the arc, the length, remember, is a measurement instead of degrees. What I would do is I'd say, okay, since the central angle is 90, the measure of the arc is 90. So I'd do 90 divided by 360. And you can see I did my math here. That reduces to 1/4. And then I do multiplied by the circumference, 2 pi r, and r is 8. So 2 pi r is 16 pi. And then 90 over 360 is 1/4. Now when you multiply fractions, you can divide. So 1/4 times 16 pi is the same thing as taking 16 pi and dividing by 4. Or you can just multiply by 0.25 if you felt saucy or whatever. So anyways, I take 16 pi and I divide it by 4. So I find out that the length of that arc is 4 pi, or 4 times 3.14, blah, blah, blah. Usually we leave our answers in terms of pi. If they want you to round your answer, you would just on your calculator do 4 and then times the pi key, and then they'd give you an answer. So on this particular problem, if I take it, I do 4 times, where's the pi key on this one? Here's the pi key right there. So 4 times pi, enter, and it gives me 12.566376061. Remember, pi is irrational. It goes on forever, so we'd have to round that. It'd be about 12.6 or so if I'm rounding to the nearest tenth. So 4 pi, or 12.6 meters. All right, here's another one. So on this one, I want to find the length of AB, BC, and CDA. So here's what they give me. They give me that the diameter is 12. They give me that this inscribed angle is 30. And they want us to find out how big is this arc, how big is this arc, and how big is that arc. In terms of, they want it in terms of the distance. So let's look at A to B. Since this is inscribed and this is 30, remember, inscribed angles are half of the arcs. So this arc would be 60 degrees. So to do AB, I'd do 60 over 360, because we do arc over 360, and then times the circumference, which is pi times the diameter, or 2 pi r. We get 12 pi. So all the way around the circle is 12 pi. So for just this part of the circle, it's 60 over 360 times 12 pi. So 60 over 360 reduces to 1/6. So I do 12 pi divided by 6, and I get 2 pi. So from here to here, that's 2 pi. Remember, all the way around the circle is 12 pi. From here to here, it's just 2 pi. From B to C, if this part is 60, this part has to be 120, because this is half the circle over there. So they have to add up to 180 degrees. So B to C would be 120. So the length of BC would be 120 over 360 times the circumference. So the circumference is 12 pi. 120 over 360 reduces to 1/3. So I do 12 pi divided by 3, and I get 4 pi. So from B to C, that distance is 4 pi. Remember, all the way around the circle is 12 pi, but this section here is just 4 pi. And it makes sense, because now I've got 2 pi and 4 pi. That's 6 pi, half the circle, because the whole circle is 12 pi. Okay, the last thing I want is CDA. That's this half of the circle over here. Since it's half the circle, it's 180 degrees. So I do 180 over 360, and then my circumference is 12 pi. So I do 180 over 360 reduces to 1/2. The circumference was 12 pi, so half of 12 pi divided by 2, 6 pi. So we said the whole circumference was 12 pi right here. Now let's look at all these parts, because AB, BC, and CDA, add them all together, you get the whole circle. If I take 2 pi plus 4 pi plus 6 pi, I do get 12 pi, which is the whole circle. So that's arc length. Next thing we're going to do is sector area. If I can find my piece of paper. What did I do with it? This is weird. I had it. Oh, there it is. Had it upside down. All right. Sector area. Sector area is like a piece of pie. All right, so you got this or cake or whatever. I don't really like cake. I like pie better. So anyways, I've got this circle. Sector area would be just this area inside of here. So not the whole circle, just the area of part of the circle. So remember, area of a circle is pi r squared. So when we do sector area, we're going to do something very similar to arc length. We're going to do the arc over 360 and then multiply it by the area of the circle. And that will give us just this portion of the area. So this is the fraction of the entire circle times the area of all the circle. All right, so in this problem here, example 3, we want to find the area of the circle. We know that this arc in here is 72 degrees, so that's a central angle. So that means this arc out here is 72. And my radius is 15. Okay, so the area of the whole circle would be pi times 15 squared, which is 225 pi. Next, we want to find the area of the shaded region. So that's this sector here. This sector represents 72 degrees out of the entire circle, which is 360. So I would do 72 divided by 360 times the area. We already said the area was 225 pi. So if you reduce 72 over 360, you get 1/5. So you're going to do 1/5 times 225 pi, which is just taking 225 and dividing by 5. So if I take 225 and divide by 5, you get 45 pi. So this section in here, just the shaded region, is 45 pi. We said that the entire circle was 225 pi. So this answer makes sense because it's only a small portion of this entire area. So we got 45 just in that shaded region. Okay, then we're going to find the area of the non-shaded region. The non-shaded region, if this is 72, remember the whole circle has 360 in it, so the non-shaded region out here would have to be 360 minus 72, which comes out to 288. So I'm going to do 288 out of 360, so that's my fraction, and then multiply it by the area of the circle. So 288 over 360 reduces to 4/5. So what you can do on this one is you can take 225, multiply it by 4, and then divide by 5. That's what a fraction means. It means multiply by the number on top and divide by the number on the bottom. So if I take 225 and multiply by 4 and then divide by 5, I get 180 pi. So I took 288 divided by 360. I reduced that fraction to 4/5. I multiplied 225 by 4, and then I divided it by 5, and I got 180. Now look at these two numbers, 45 pi and 180 pi. What do they add up to? They add up to the entire circle of 225 pi. So these are just fractions of the circle. The fractions are the arc over 360, and that tells us the portion of the circle that's just in that one little sector. Last one. This one does a little bit of arc length and sector area. So here I've got 100 degrees as my central angle, and my radius is 9. So the first thing it asks me is, what's the length of the arc? Length is based off of circumference. So my circumference is 2 pi times 9, which is 18 pi. And then the measurement of that arc is 100 degrees out of a total possible of 360 degrees. That reduces to 5 over 18. So if I take 18 pi, multiply it by 5, and then divide by 18, I get 5 pi. So that's the length out there. When you're doing the area, we would still do 100 over 360 because it's arc over 360. And then for the sector area, we would do pi r squared. So that's 81 pi. So if I take 81, multiply by 5, divide by 18, I get 45 over 2. And that's it. All right, have fun. Hope you guys are all doing well. That's it. Bye-bye.